Well, welcome everybody to Radio Pi. I'm Nick D'Orazio. I'm a meter producer here at OSIsoft, which is now part of aVEVA, if you haven't heard. A topic of great interest in operations is the cooperation, the collaboration between IT, information technology, and OT, operations technology. And we have a guest here who spent 25 years, his training is in information technology, his educational background, and he spent 25 years in operations doing projects, major projects, where he's managed large things like the installations of compressors in entire packaging lines. And he is our guest today, so we're really interested in talking to him about that collaboration. So welcome today, Emelio Anglés. He is an information technology engineer at Kellogg. Good morning, Emelio.
Good morning, and thank you very much for inviting me.
Great, great. Well, thanks for being here. Also today, co-hosting is Ted Combs. Ted is the industry principal in food, beverage, and CPG here. Hello, Ted.
Hello. Thank you for having me.
Great. And let's get started by, if you could tell us, Emelio, tell us a little bit about Kellogg and what your job is.
So, well, I am responsible for ensuring that Kellogg manufacturing bulk is in Spain, so adopts the right technologies in order to achieve the business goals that we have in safety, food safety, delivery, cost, and continuous improvement, basically keeping our operation technologies reliable and cost-effective. My background is in IT engineering, information technology. I am an information technology engineer. And in 1999, when I started in Kellogg, I started in the corporate IT, working in different IT projects related with financials, marketing areas, and so on. And later on, in 2005, I was moved to operations, to engineering department. And currently, I am the manager of a department that we call here in Kellogg's Power Control and Information Systems. And we are a team of 6 people plus some contractors.
Emelio, can you tell us how you made the move from IT into operations?
I was part of the team that implement and install OSIsoft Pi in Kellogg's manufacturing valves in order to count cases that we produce in our packing lines and send this information to SAP. So, and after this project, the company decided that they need someone in the plant in order to evolve the OSIsoft system in the plant, and I started in the engineering department in manufacturing. So, and since then I've been working there, and now the last 15 years mainly, apart from doing different improvements in all the network, all the controls, PLCs, and all this stuff, networks, okay, and different projects in order to upgrade all PLCs that we have in the plant. So now I am working integrating the two worlds, the IT with what is called operation technologies, OT. So, and also now I am part of what we call a Smart Factory project, which is a project that we are implementing in Europe and also around the world in order to digitalize all our manufacturing plants.
So how do you think your background in IT has helped as you're working on these very engineering-heavy OT projects?
It makes me my life easier here in the plant, because during the last 15 years, so we have been upgrading all our infrastructure in terms of PLCs, connections. Now we have a big deployment of optical fiber in the plant. Okay, and all this connectivity has been done along with our IT department in order to create a solid infrastructure that allow us to has a reliable network in order to be able to access to all our wide PLC network that we have here and access the data that now is key in order to implement our smart factory project that at the end is a digitalization of our manufacturing plants.
Emelio, that's really interesting when you talk about the move from the IT side over to the OT side and that discussion of creating a data infrastructure on the OT side. And I'd be really curious to know, once you were building that data infrastructure, was it something that started kind of from the ground up, or were you borrowing things from the IT side? Did you, for example, just work with the master data management and the master data management governance that was already in place? Can you are there any insights that you can share there?
Let's say that when I joined the engineering department, I found a plant that it was what is called now Industry 3.0. So it was just aisle of automation. I found a lot of PLCs that was just standalone. So and then what we did was to start a project. We did a project plan of 5 years in order to invest in different areas of the plan and start to, first of all, upgrade the PLCs. Okay, upgrade, connect, and once we have the connectivity, we connect to our data infrastructure that in this case was OSIsoft Pi. But during these days, so I remember that we had almost 5 different protocols in the plan, and we had 5 different OSIsoft Pi interface in order to connect to all this data. So and then, when we step by step, so as I said, during this 5-6 year plan, so we were replacing the old PLCs, connecting, and in this project, during this project, we take advantage of the project in order to remove the old communication buses. Okay, so. And once we have all the plan with TCP and IP connectivity, then we did a project in 2013 in order to replace all the external, the different communication interface for just one communication interface, the one that we have right now, which is OPCDA using KeepWare software. We use Keep Server, and we just have one communication protocol. At the end, we collect all our data with just one OSIsoft interface, which is OPCDA, and also the last years that we have installed new PLCs, we are already connecting using OPC UA. During this process, to have a good relationship between our IT department, corporate IT department, and the OT side, it was very value added because it allows us to create a standard network that allows us to escalate quickly, and now we have a system that allows us to implement some cybersecurity stuff around our plant because we have a good design, and the design has been done between OT and IT, not just OT or so. We have been working together during this year, probably because my background was from IT and I had some contacts there, so I know very well what are the next steps that I have to do.
Having that data available to you, what kind of results have you been able to get? Is there anything you can point to as a concrete improvement from having that data?
Yeah, for instance, so we are using this data, as I said before, for the autonomous maintenance project. And for instance, one of the KPIs that we measure at daily basis, also at shift basis, is the mean time between failures. And for instance, we have increase our mean time between failures in some packing lines in more than 20, 30, and even 50%. Now we have data in real time, and we are able to see which kind of actions we have to do in the lines in order to improve this, in this case, this MTBF.
So you're expanding this to multiple plants, and you have this visibility, and you're doing some modeling, and it's opening up communications. Has there been a significant change in almost how you conduct the business or approach the business? For example, maybe somebody in a different country is having a problem, and now by virtue of the fact that everybody's approaching it the same way, has the same tools and practices, is there kind of an improvement in collaboration and communication and problem solving?
Yes, in fact. So I've been named as a subject matter expert for OSIsoft Pi here in Europe, and I am helping the other serial plants in this case in order to standardize, to put the information in the right manner in order to have in all the plants, okay, the same source of truth. So that if we check the MTBF for one bagger, so this bagger can be compared. So now, so we are able to compare the Spanish baggers with the English baggers. You know what I mean? Installed there, because we have data that is we are measuring the same data, and we are using the same kind of source of information.
Okay. Well, that's great. That's the perennial story. We've heard that over and over again. Pat Kennedy, our founder and president, likes to tell the story of how, well, a lot of times your morning shift meeting will consist of two people bringing two sets of data, and then, spending 2/3 of the meeting arguing about whose set of data is right. Have you experienced any of that where one source of the truth fixes that?
Yeah. So this is what. For instance, in every morning, as all the manufacturing plants in the world, I think, so we do the overproduction meeting, and now the 70% of the information that is coming from the in the production meeting is coming from our packing line analytics system. And all the people of the different areas, and also the maintenance people, so is using this information, and this is very, very helpful, because we can concentrate not analyzing the past. Okay, we can focus in the present and also in the future, because we have real data. All the people is using the same, as you said before, source of truth. So and for instance, production meeting that I remember, maybe a production meeting could take usually 45 minutes, 1 hour, and now daily, sometimes the production meeting that is 30 minutes, sometimes we finish in less than 15 minutes. So this is an important reduction, because we focus in the present, the future, and basically because there are no discussions about the consistency of the data that we are dealing in the production meeting.
Okay, great. So I'm curious, have you been able to reduce energy usage, just this increased visibility? Have you had any like easy wins like that just because people have better visibility?
Yeah, so in fact, so we started a project in 2005 where we install or we deploy a lot of electrical, gas, compressor, steam meters around the plant. So we connect all these meters to our OSIsoft Pi, okay? So and then we start to measure where we are spending more energy, okay? And during these years, we have done different engineering projects in order to reduce our energy consumption. And in fact, we measure the energy with we use a KPI which is kilowatt per ton produced. Okay, so you have to take into account that in 2005 we had an energy usage of for every ton we spend. Let me remember, if I remember well, is 1,265 kilowatts. Okay, and right now, for instance, last week our usage was that less than 1,000 kilowatt per ton. Okay. So obviously we have done different, as I said before, engineering project, but currently we have a nice energy dashboard that we call energy dashboard in that is made with PyVision or PyProcess book, okay, that allow us to control which areas of the plant in real time are in production and the energy consumption is okay, or which ones are stopped, for instance, for maintenance, for cleaning, for any reason. And in that areas, we have equipment that is started and is consuming energy and is not producing. And we have set up some kind of alarms, okay, in the process book that allows the operation people to, in this case, stop equipment that are not in production. Okay, it seems something a little bit silly. Okay, but at the end of the year, it helps us to have information that is available for not for the management. For the operator that is in the line, it allows him to make actions in order to reduce energy. And at the end, this is small things, because the big project is a big project. Okay, we are going to change a boiler that is more efficient, for instance. This is an engineering project, but there are a lot of small things that happen in the plant. Like, okay, I go there, I have to clean some equipment. So the equipment is not in production. I start the equipment, okay, clean something, but I finish my shift and I forget to stop the equipment. Okay, this kind of things happen in a manufacturing plant, and sometimes the equipment is there running for hours and hours. Now, with this system, allow us that when the guy finished the shift, the people that came in the shift after, they are able to see if they are consuming or not energy in depending on the area of the plant. So.
Okay. Well, I think it must be a rule of human nature once you make something more visible. I mean, because we see this all the time when people have better visibility into the data. Facilities especially, anybody who can control a thermostat, all of a sudden people just respond better. So a quick question about notifications and email. Do you implement any kind of email notifications where people can be informed of, automatically if there's a problem that you've defined?
Yes, so we are able to send a notification to our maintenance people when the mill has run, for instance, more than 10,000 hours. Or, for instance, when the mill has done more than 1 million of cycles. We send a notification to the maintenance people because depending on the number of RPMs, they have to do some preventive maintenance in the mills. Another use case is, for instance, we have big silos of raw material. So and then we set up an analysis in our PyIF. We have a PyIF. We set up the notifications. And now at daily basis, every 12 hours, we send to our raw material supplier, in this case for the cream, chocolate cream. So we send a daily notification informing them, and it allows us to have a better inventory control.
Emelio, can you just describe a little bit the approach you took with the modeling for the packaging lines?
Yes, of course. So when we start with this application that is mainly based in SAP, we found that there were some calculations that initially we did using the typical performance equation that has a pi, a size of pi. So, and we found that it was that we were not able to have the accuracy in the calculations. For instance, the status of the line, or for instance, the stop reason of the line, or the stop reason of one machine, or the status of one machine. Okay, so and then because we have to take into account different pi tags, okay, and different conditions in the line. So and then we ask the Spanish OSIsoft guys, because we have a direct support from here. They recommend us to use PIF and the analysis in order to do this kind of complex algorithms in order to calculate the status of the status and the stop reasons. So, and in order to do that, so we create a model of our packing lines using PIF, and it helps a lot in order to have now a very accurate information and also consistent information. So it helps us a lot for the modeling. And also now it's very easy because when we started the project, we just have 6 packing lines in valves. So, and during the packing line analytics project, so we installed a new packing line. So, and then in order to set up the new packing line in the system, in the packing line analytics, so it was very easy because it's just we created we used the PIF templates in order to just create line, bagger, cartoner, or whatever requirement that we have in the line just in 1 minute, because it's we have a good model of the line, of a packing line, and also of the different machines that we have, or the different equipment that are involved in the packing line.
So essentially, you were able to create, refine the model to make it just like you want it, and then once you wanted to replicate that, it was as simple as copying that template over, pasting it, and going. So very efficient and effective.
Exactly.
Thank you. That's helpful.
Okay. Well, that's it. We're at the end of our hour. I just wanted to ask you some quick lightning round questions, because I know, we're in operations, right? There's some things in operations that only people in operations see. It kills me that people think everything's just smokestacks and, waste treatment, right? What's the prettiest view on any of the sites you've ever been at Kellogg? I imagine you've been to a lot.
Yes, for instance, in a powder plant. So when we have big bags, okay, of powder of different. So when sometimes the big bag is it goes down in the floor and explodes, okay, and then the operator gets a lot of powder in their clothes and so on, and it's completely white, for instance. So I saw this image here in the plant sometimes, or even covered with chocolate, with chocolate. Covered with all the body, all the clothes with dark chocolate.
That's pretty cool.
These kind of things happen in a food company.
Okay, so especially since you've got an IT background, what's the coolest spreadsheet or calculation or even a bit of code that you've ever done in your career? What's the neatest thing you've done?
This is a difficult question because for sure I have some examples, but for me, one of the calculations that I am more proud of that is an Excel spreadsheet that we have in order to calculate at shift basis the raw material consumption from our extrusion process. You have to take into account that the extrusion process is the 40% of our production. So then to have, in fact, it's at shift basis, the raw material consumption, and is key for us in order to control the cost. So and I remember that when we did this Excel spreadsheet, that behind that there are some Visual Basic code as well. So for me is one of the things that I am more satisfied.
Well, that's nice. That's nice. So now, since you come from an IT background, I'm just curious, and you've gone into OT. Are you, like most engineers, chemical, mechanical, electrical engineers in OT, do you have some kind of a broken piece of equipment or maybe a fried motherboard or something that you keep on your desk as a memento of something that went wrong at one point?
Yes, in fact, I have a PLC, so an old PLC that we had a problem, an electrical problem, and it was burned.
Okay.
Correct.
Well, I really appreciate your time. Thank you so much for sitting down with us. Again, we've been talking to Emelio Anglés from Kellogg. Thank you so much for joining us.
You are welcome. So it has been a pleasure, and thank you very much for inviting me to this podcast.
Great. And thank you, Ted Combs, for joining us as well.
It's my pleasure. Thank you.
Okay. Well, we'll see you all in 2 weeks. Thanks again for joining us. Bye-bye.